It's your boy, AC. Welcome, how to do. Let me show you a little math. It's what we do when you're at school, cause you're a fool. Alright, my friends, so before we begin to learn the introduction to square root functions, let's take a look at linear functions. Now, we already know, right, if we were to make a quick table and graph, well, that means that we're starting our y-intercept, our starting point, is when x is equal to 0, and we can just look at the equation. Well, that's 2, or we could plug it in. 0 plus 2 is 2. Boom, so we're here. And then every time you go down a row like such, right, well, we're plugging in 1 in for x. We're plugging in 1, so 1 plus 2 is 3. Boom. When we plug in 2 for x, we get 2 plus 2, which is 4. Cool. And now you'll notice, right, we get, and I'll just fill in the rest now, looking at the pattern, we get a straight line. Okay, and it makes sense. This is called linear functions. It makes sense that it's a straight line because really we're just adding by 1 every single time, and over here we're adding by 1. Okay, so we should expect this to just naturally be a straight line because we're always adding by 1 on the grid. Now, when we go to look at square root functions, you'll notice the shape is different, and we're going to try to make sense of that. But before we do, we want to introduce the square root function. And basically, the only way to make sense of this is like such. We do, what is the square root of 16? Well, essentially what we're asking is, what two numbers multiplied by themselves gives you 16, right? And we're only thinking about positive numbers for now. Well, what about 4 times 4? 4 times 4 is 16. So we know the square root of 16 is 4. So let's put it here. The square root of 16 is 4 because 4 times 4 is 16. Okay, and we're only going to look at positive numbers right now. All right, we're going to only look at positive numbers right now because later on you're going to learn that we're going to put this little plus on the outside and this minus on the outside. But for now, don't worry about that. Let's just understand this. Square root of 1. Okay, so we're saying what two numbers multiply to give you 1? What two numbers multiply to give you 1? But they have to be the same. Well, it turns out 1 times 1, right? So we know the square root of 1 is 1 because 1 times 1 is 1. Well, what two numbers multiply to give you 9 that are the same? Well, 3, right? The square root of 9 is 3 because 3 times 3 is 9. And same thing over here. Well, the square root of 25 will be 5 because 5 times 5 is 25, okay? Cool. And for some of you who are saying, well, negative 5 times negative 5 gives me 25. You're right. And so we can actually put a negative on the outside of the square root to do that. But for now, we're just looking at positives, all right? So let's take a look at down here. Well, why is it not possible to do the square root of negative 4? All right, well, what we're asking ourselves is, what are two numbers that multiply together to give you negative 4? Okay, well, naturally you might ask yourself, what two numbers multiply to give you 4? Well, we know 2 times 2 is 4, but this is a problem. Let me write it up here. This is a problem because 2 times 2, my friends, is positive 4, and we want a negative 4. So what naturally would you try? Well, my friends, we would try negative 2, but negative 2 times negative 2 is positive 4, so that doesn't work. Well, what about negative 2 times 2? Hey, gotcha. It's negative 4. But my friends, be careful because negative 2 is a different number than positive 2. So recall, in order to do the square root, they have to be the same number. So this is not possible. Okay, so since we can't take the square root of negative 4, we ask ourselves, what is the very first number that we can take the square root of? Well, you might think 1, right? But there's a number before that, and that's 0, right? Well, what's the square root of 0? It's 0 because 0 times 0 is 0. So this is our starting point, right? And just like linear functions, how over here, our starting point, our y-intercept in this case, is 0, 2. It's always when x equals 0. Well, in this case, our starting value is the same when x equals 0, and we can begin. Well, what's the square root of 0? Well, it's 0, so we can plot this point here. Well, what is the square root of 4, right? Notice how we're going to, what is the square root of 1? Well, we already did that. It's 1, so 1 comma 1. Cool. All right, you're thinking to yourself, cool, I'm starting to make sense of this. Well, I'm going to skip the square root of 2 because the square root of 2 is going to be like 1 point something, right? What two numbers multiply to give you 2? That's the same. That's a decimal. Let's ignore it. What's the number that maybe comes easiest? And well, that's the square root of 4, because what two numbers multiply to give you 4? Well, that's 2. So square root of 4 is 2 right there. Okay, and this is the parent function. Parent function is the 1. So here's our parent function. Let me just rewrite it. Okay, just to introduce, it's the square root. This is a new parent function. When we say parent, that means this is the function that has no numbers being added next to it, no multiplication. It's just the square root of x, right? It's just the one that is not being adjusted or changed for at all. And we're plugging in these x values into there. Okay, well, what's the next number to take the square root of? Well, it's 9, and the square root of 9 is 3. Okay, and we might ask ourselves, why does this not make a straight line? Notice how it's kind of curvy, right? And if you make a little table like we did before up above, 0, 1, let's just go 4, 9, right? Because these are the numbers that we can take the square root of: 0, 1, 2, 3. Well, notice here, right? In this case, we're adding by 1. For now, we're adding by 1 on this row here, but over here we add by 1, right? 0 plus 1 gives me 1. Well, this is plus 3. This is plus, well, 5. So notice the difference here is that over here we're adding by 1s, but over here we're not adding by the same thing anymore, right? And it causes this shape here. Well, again, well, why would it cause this shape? Well, think about it. If I plug in a big number like 9, I'm getting a smaller y value. Okay, if I do the square root of 100, what am I going to get? Well, my friends, I'm going to get 10, right? So as I plug in really big numbers, my y values are barely going up. So as I keep going to the far right, my y values barely go up to 10. So you should expect your line to grow really slowly, right? Because your y values are not increasing very fast. Your x values keep increasing, but your y values barely increase. Boom, right? Over at 10. And that's why it's going to be, sorry, I should maybe make it more accurate, something like this. It's barely gonna grow, because as we keep going all the way to the far right at x of 100 or 200 or 1,000, our y values continue to stay relatively small relative to our x values. So as our inputs, our x values get really large, our y values are growing really slowly, and it's gonna give us this kind of weird graph here, which looks something like that, right? Which is our square root parent function. Okay, hopefully that helps you to understand the square root parent function and why it makes the shape that it does. Take care.